right, so picking back up, number 31, what is the probability that the player makes at least one three-pointer? Well, let's see what they're talking about here. So the scenario we're going to use is that Jason knows that his favorite player on the Raptors basketball team scores 25% of his three-point attempts. Okay, the player attempts 10 three-point shots in a row in practice, and they want the probability of at least one. So once again, at least one is greater than or equal to 1. Okay, so we know the probability of him making it, scoring, is 25%, and I want at least 1. So to do this, we would do the same thing we were doing above. We have a binomial situation. They either score or they don't score, okay? So since it's greater than or equal to, it's going to be 1 minus a binom CDF. Remember, if it's greater than or equal to, it's 1 minus binom CDF. There's 10 three-point shots. The probability of success is 0.25. And then once again, let's think about what we would get rid of. So if I want at least 1, I want 1 or more. So I would get rid of the 0. Technically, since you're just getting rid of one thing, you could switch this to a P of x equals 0, but it doesn't really matter. So 1 minus binom CDF of 10, 0.25, 0, I get 0.944, and that's letter A. What is the probability that the player will score exactly 3 times? So exactly 3 times means x equals 3, and that's the definition of our binom PDF. So a binom PDF, there's 10 shots, 0.25 that we want to score on exactly 3. So if it's exactly an amount, you do second vars, binom PDF of 10, 0.25, 3. That's how I get 0.250. So letter B. All right, and 33, what is the expected number? Okay, something you guys should know for this semester is expected number is the same thing as mean. So what's the expected number of three-pointers that the player will make? Well, remember, to find the mean of a binomial distribution, you just do n times p. So our sample size, which is 10, times the probability of success, which is 0.25, and that's how we get 2.5. You could also, I guess, technically use a table, but that'd be really, really intense. Wouldn't recommend that. I'll show you a table version where we find the mean in the short answer of this review. Also keep in mind that I realize you cannot make 0.5 of a three-pointer, but you're still going to leave that in your final answer because this is a statistical value. Okay. So 34, there are 10 members on a committee. The probability of any member attending a randomly chosen meeting is 0.9. The committee cannot do business if more than 3 members are absent. So what's the probability that they cannot do business? So let's think about it. If I just read this as is, I'm like, oh, I need the probability that more than 3 members, because I cannot do business if more than 3 are absent. Well, you need to be careful if you're going to do it this way, okay? More than or equal to is a 1 minus binom CDF. Let's see, there's 10 committee members, but my probability that they gave me is that they actually attend. This is that they're absent. So if the probability of attending is 0.9, the probability that they're absent is 0.1. So it's kind of like what I talked about in number 30 with that second choice. 0.6 was not read. Well, 0.1 is not attend, aka absent. So that's the probability that I want because I want more than 3 members to be absent. So they cannot do business. And once again, if I want more than 3, since I said more than 3, I can't include 3. So I want 4 or more members. So the last number I do want to get rid of is that 3. So I have 1 minus binom CDF, of 10, 0.1, 3. and that's how I get 0.013. So just be careful with the wording, okay, and what probabilities they give you. Let's make sure we have time for these next two questions. We definitely do. Awesome. Okay, so the next two questions, we have times for rats to complete a memory maze. They have a normal distribution, so we're switching gears here. Okay, this is not going to be binom, CDF, or PDF. This is a normal distribution. The mean is 45 seconds, so mu is 45, and the standard deviation is 3.5 seconds. Mice have times that are normally distributed. Oh, okay, so I just realized these were rats. So I'm going to do mu sub r and sigma sub r because those are rats. Then we have mice. So mice have a mean of 42 seconds. So mu sub m is 42. And a standard deviation, so sigma sub m is 4.4. If a rat completes the maze in 44 seconds and a mouse in 41 seconds, which did better compared to its peer? So remember, if I ask you to compare two different distributions with different means and different standard deviations, that means you're going to be using a z-score. Okay, z-score just puts them on an equal level playing field. So let's find the z-score of the rat first. So z-score of rat, remember the z-score formula is value minus mean. So the rat's value is 44 minus the rat's mean of 45 divided by the rat's standard deviation of 3.5. Just to show you what I'm using there, z-score equals value minus mean divided by standard deviation. So typing that in, 44 minus 45 divided by 3.5, and I get negative 0.286. Then let's find the z-score of the mouse, which did the maze in 41 seconds, but now you're going to use the mouse's mean. Because once again, you're trying to see who did better relative to its peers. So you use the mouse's mean of 42 divided by its standard deviation of 4.4. And I get, negative 0.227. And we want to know who did better completing the maze. Well, think about it, guys. If you want to have a better time, that means you want to be lower than the mean. So the one that's more below the mean is better. So in this case, the rat went further below the mean than the mouse. So the mouse is out, and it's because it's more standard deviations below the mean, because in this problem, that's a better thing. And the last one for page 4. So if a mouse has a z-score of negative 1.2 and a rat has a z-score of negative 2.1, which one was faster and by how much? There's a couple ways to do this one. There is a shorter way that I'm going to show you, but I'm going to go ahead and show you the longer way. Checking my time. So my z-score of my mouse. So my mouse had a z-score of negative 1.2. That equals the value, which I don't know, minus the mouse's mean of 42 divided by its standard deviation of 4.4. So I'm going to multiply both sides by 4.4 to get that numerator by itself. So I get negative 5.28 equals x minus 42. And then just add 42. Once again, like I said, there is technically a faster way to do this problem. I'm just showing you the way with all the work, just so that way you can see. Okay, now let's find the rat. So the rat had a z-score of negative 2.1. So its value I don't know, minus its mean, which is 45, divided by the standard deviation of 3.5. So multiplying both sides by the standard deviation. And then adding 45. Gives me 37.65 for the rat. So to see who is faster, hopefully you can easily tell that the mouse was faster. So it's A or B. And then if I just subtract those two things, so 37.65 minus 36.72,